are grown out of, root down. So we're going to talk about some methods of dealing with that and helping root masses of plants to regenerate to what they should be. So be going more into detail about that as well. And then finally, we'll be talking about irrigation and earthworks. Being here in the desert, pretty obvious water is super important. And there's all sorts of different ways that we can get water to plants and help retain it so that the plants get the most out of it. So we'll be discussing this. So this is a cool picture from the farm out in Mescal. A bunch of food stuff. You can see some strawberries, some other seedlings popping up, along with a bunch of native annuals and perennials. Oh, that's fine. So the idea of presenting an image like that is that we emphasize integrative planting. So instead of compartmentalizing and putting all of our vegetables and medicine plants over here, and then native plants over here, and the exotic plants over here, we try to integrate plantings as much as possible and get things working together to save us, ideally. So first topic, soil components. Soil is not just dirt. Contrary to popular belief, it's made up of all sorts of different things, and it is a teeming substrate full of life. And we want to get into, the different components of the soil, the different things that live in the soil, so we can get a better understanding of it, how it interacts with our plants that we're trying. So organic matter, what we mean by that, decomposing plant and animal material, compost, mulch. So, when you go out into nature and you're taking a hike and you see the forest floor, you see a bunch of dead and decomposing stuff on the ground. It's removed and put in bags or in trash cans, right? It's left there, and it's there on purpose. All of that organic matter decomposes and feeds the soil life and turns into healthy topsoil. So we really emphasize organic matter being present in the soil, on the soil, around the soil, everywhere we can get it. So, and we'll go into more detail about how to be strategic with that and get soil coming back to life the way that we want to. So, next thing is mineral content. So, sand, clay, silt, rock. As many of you know, I'm sure digging out here in the desert, it's not all the same. It's not all just sand. It's not all just clay. The soil has different pockets all throughout the desert here that are made up of primarily one of these mineral components, right? So if you have really clay-ridden soil, right, it has a certain color, a certain feel. If you have really sandy soil, same thing. So we always want to have that in mind. We want to know what we're starting with. Can everybody see us okay still? So we want to know what we're starting with so that we can figure out what the soil needs, right? A soil that is very sandy is going to need different amendments and different help from us than clay-ridden soil. So knowing what you're starting with and knowing what the primary mineral content is in your soil is a great place to start, because then you know what you need to do next. Moving on to bacteria. Bacteria is kind of a bad word. Most people associate it with the negative, but there are a great number of beneficial bacteria all around us, but especially in the soil. And we try to pay mind to that, of course, and give that healthy bacteria what it needs. Feed that bacteria so that it can do the jobs that we need it to in the soil. which is breaking down different mineral and organic components into nutrients that plants need to uptake. So there's there's two primary kinds of bacteria when it comes to dirt. We have aerobic bacteria and anaerobic bacteria. So when you have really healthy soil or really healthy compost, it has a certain smell to it, and it's usually a pleasant one, right? So that is the presence of good, healthy aerobic bacteria. And then I'm sure anybody who's tried doing home composting has experienced at least once. Sometimes it can stink really bad. And that is the presence of anaerobic bacteria. So if anybody smelled that smell when you are, saving your food scraps to put into the compost pile or what have you, you'll never forget it. That's anaerobic bacteria. And that's something that if it is present in soil amendments or in soil that we're working with, we immediately get to work on remedying it with the proper amendments to alleviate that problem and get rid of the anaerobic bacteria. So smell is the main indicator. Fungi is another critical soil component. So everybody knows what mushrooms are. And fungi and mycelium is like the other buzzword, I suppose, that goes with it, is present in all soils. And it's one of the most important components because mycelium creates a network, if you will, underneath the soil. Looks a lot like roots going out. And what it does is it attaches to root nodules on plants, right? And it helps to direct water and nutrients in the soil so that the ecosystem is in balance and in harmony. So it's a very critical component of soil that we are lacking here in the desert, by and large. There's very, very little fungal activity in our native soils. And that's a large part of why it's so difficult for us to be able to do different gardening methods and things like that, because the lack of nutrient availability and the moisture as well. So getting fungi into the soil, helping to feed the fungi just like the beneficial bacteria is a great way to establish healthy soils. Some of the inhabitants of soil are invertebrates and vertebrates. So by invertebrates, we mean like bugs and stuff primarily, earthworms, ants, termites. Vertebrates, gophers, prairie dogs, moles. A lot of people consider these critters pests. We do too oftentimes, but they are, again, a critical part of the soil. They're always present in it. They're tunneling through, making different passageways for water and other nutrients to go all throughout the soil. And it's something that's always going on. So it's something that we want to consider when we're trying to regenerate soils. So I think that covers everything that was on here. Before we move on, does anybody have any questions about what I was just rambling about? Good deal. All right, we'll move on. So this is a sycamore tree that we planted somewhere between 1 and 2 years ago. It's a lot bigger than that now. And you can see what we did around the bottom here planting this. So after planting it, we built what's called a well around the tree. So basically raising up the dirt around the drip edge. So basically where the growth goes to on the tree, you can see that goes down right there, hopefully. So what we're doing is we're putting a berm around the drip edge of the tree, And we're trying to retain the moisture from the irrigation and when it rains, so that the water is going directly down over the roots of the tree. So not having any earthworks there that would help to retain the water runs the risk of that water running off and going somewhere else, not going to the roots of the tree. So as protocol, when we plant trees, we put that well around there. And then we try to fill it up with mulch, typically wood chip mulch. We really like a product from Tank's Green Stuff. It's called Play Safe. It's what they use on playgrounds and stuff like that. It's a very fine cut pine wood mulch. It is really great for retaining moisture, for housing beneficial bacteria and fungi, and breaking down over time as organic matter to turn into healthy topsoil. So we fill up the wells with that. That's going to, like I said, help to keep that water in there. And it's also going to, by covering the top, it's going to prevent evaporation of that water. So when we water in our gardens and landscapes, you'll often see the water just going right on top of the dirt, and it just sits there until it sinks in, right? Well, while it's sitting there, if the sun's hitting it at all, it's evaporating and it's going away. So when we have mulch around our irrigation, it helps to keep that water there and prevent that evaporation. So it's another thing that we try to do regularly. So next slide. So yeah, those are a couple of the planting techniques that we do. I think I touched on a little bit in the beginning how there's different kinds of plants, trees, shrubs, what have you. And all of those kind of have different requirements for irrigation, soil conditions, planting depth, right? How far down in the soil or above the soil it is, and the amendments that we've been talking about as well. So anything you want to add to that? Okay. So yeah, we'll just jump right into it. So hole size should fit the root ball of the plant, possibly more if needed. So depending on the size of what you're planting, right? If you're just planting a small 1 gallon plant, 5 gallon plant, usually the hole fitting the root ball is adequate, right? When you get into larger stuff, 15 gallons, 25 gallons, big trees and what have you, we typically try to open up the hole a bit more. And the reason for that is we want to be able to get the additional amendments and stuff that we're putting in the hole for that tree or shrub, whatever. And we also want to break it up and open it up so that the new root growth is able to spread out and actually penetrate the surrounding soil. So, we were talking about mineral content a bit earlier, and I'm sure some of you dug in caliche before, and it's basically just, making a hole in some natural concrete. In applications like that, we want to open up that hole a little bit more and break up some of that compacted, really hard soil so that the soil biology can get to work. And
we'll even drill through caliche with big drill bits and such to punch holes for drainage and to punch holes for nutrients to get down into the caliche and start actually dissolving it, breaking it apart.
So there will be times we actually just planted a large desert willow last week. It was a 25 gallon, and it was going in a huge hole that had caliche silt at the bottom, and it just kept going. I used a drill bit probably about that long and punched holes in it, and it was still caliche all the way down, right? So just perforated it, punched holes in it, And like Charles was saying, that's going to enable water, nutrients, other things to get down in there and start breaking that. Um, so uh, is it for whole size, yeah. Right? So moving on to planting depth. So if y'all don't know what a root crown is, so basically where the roots start on the plant, you'll see a flare coming off of the trunk or the stem of the plant. And that's what we're focusing on, talking about the root crown being 10 to 20% above grade. So what we mean by grade is ground level, right? And the reason that we say that is when you're planting a plant and it's coming from a nursery, it has a totally different soil than what you're planting it in typically, right? And with additional amendments that you might be putting in the hole and what you plant, what's going to happen over time, pardon, what's going to happen over time is that plant, that root mass is going to sink. It's going to sink down as the soil compacts and water pushes it down. I'll figure this out eventually here. All right. So we want to anticipate that ahead of time. So planting 10 to 20% above grade is going to account for that sinking down over time. And we don't have to worry about the root crown, that flare that I was talking about, getting buried. Because when it gets buried, the plant, the tree, it can't breathe anymore, essentially. So you see a lot of plantings here in town where things were planted too deep. You know, it wasn't accounted for ahead of time, planting it above grade, and those things have sunk down, and now those plants are struggling. So try to anticipate that ahead of time. 10 to 20% above grade. Bigger stuff, more towards 20% above grade. Smaller stuff, more towards 10.
Yeah, you all ever seen mesquite trees out there and they're stunted, they're small, and they kind of grow out and down? If you start paying attention, you'll see some trees like that, and that means they're too deep. And we've actually gone into landscapes where the tree is stunted, it's growing down, it looks very odd. And you can actually dig that root crown out, rock around, create a basin, whatever you need to do, and they often will recover. Some of them are just done for, but if you catch them early enough or at the right time, you can rehabilitate.
All true. Moving on to soil amendments. I'm sure like in reading gardening literature, what have you, when people talk about soil amendments, they often talk about top dressing and applying it from the top down. And that works great most other places. Here in the desert, because our soils are so depleted, we've tried to, what's the word for it? I suppose streamline that process and get soil activity going as quickly as possible. And we found great success with putting soil amendments under and around root balls when you plant. Of course, top dressing is fine and encouraged, but getting it under and around the root ball when you plant is really critical for establishing the plant itself and good, healthy growth in the future. If you can put a plant in the ground with all of the amendments and the things it needs to get established, as opposed to top dressing and having that root system wait for everything to sink down and be available, then you're going to have much healthier plants, much happier plants. We have a fertilizer mix that we make with different organic matter, different stages of decomposed organic matter that's all combined into one mix to account for all of that. So we want to make nutrients immediately available to plants when they go in the ground and we want them to be available to plants down the line. So that's why we mix different stages of decomposed organic matter together, meaning finished compost, finished fertilizer, but also things like fine mulch, wood chip mulch, yeah, things like that, to where those things will break down over time and make those nutrients available down the line. So by putting it under and around the root ball, it makes it immediately available and available down the line. And then one more. Earthworks, we talked about that a bit, like with the well around the tree in the previous picture, but there are also other earthworks that can greatly contribute to regenerating soils in our landscapes here. Y'all are familiar with rainwater harvesting. There is, as it's known, passive and active rainwater harvesting. So passive meaning earthworks, things that are directly in the ground. Active meaning people stuff, infrastructure, gutters, rain tanks, things like that. Rain basins, berms, swales, those wells that we were talking about earlier, all beneficial earthworks that should be implemented in our landscapes and gardens to catch rainfall, retain it, and not let it leave the landscape and go elsewhere. Okay, now you can go.
So
go ahead.
This is the mix that we make, close up of it. And we're going to get into the components of this. Next slide, please. So we're going to get into all the components of the amendment mix that we have. Sweet. Compost. So compost feeds many bacteria and many other organisms. It comes in different consistencies. If you go to tank screen stuff, you get compost, you're going to get something that's black and that's powder, right? You go down to Sierra Vista, to their municipal composting facility, you're going to get something with varying sizes of organic matter and different levels of composition, which we encourage. So they fill different roles, but you know, your home compost, at least mine, is usually pretty chunky, and there's a lot of things that haven't even broken down yet in that. Fine mulch. Fine mulch is basically needle-sized pieces of wood. It's very, very fine wood. So as that breaks down, it's going to feed bacteria. Bacteria feeds on compost. Fungi feeds on wood. So this is almost compost, right there between the two. And then we also use a fertilizer. You know, we like Tank's Super Mix. It's a good fertilizer, locally made, right on. And then we have wood chips. So this is mostly going to feed the fungi. Most importantly, they need wood. They eat wood and turn the wood into compost. So we need to have all those different sizes of organic matter. And that comes in different consistencies too. We like a smaller wood chip. Sometimes, depending on what we're planting and what we're doing, we'll add in some bigger wood chips, chunkier bark mulch, it's called at times. And then we have mycelium and beneficial bacteria, usually in a powder form, really easy to apply, really potent. And that's to inoculate that soil biology. You know, you don't need a lot of it, but you need a little bit of it. It's very important. You know, we like to use like 10 types of different beneficial bacteria, 10 types of mycelium in that inoculation. And then we use zeolite. This is a clay. It's from when magma hits seawater, and it's complex, molecularly speaking, very complex. So it holds on to water, holds on to nutrients, and does a slow release of those as the soil and as the plants need it. Okay, a basin. It's pretty. We love flowers, etc. So application at scale of these amendments, of this mix. So it's important to do this in proper ratio. You know, you're not adding to a wheelbarrow, you're not adding 1 gallon of zeolite. You know, you're using 1/80th, right?
It seems
So
like a really arbitrary number, but it's somewhat accurate.
it's pretty accurate.
Basically, if you can imagine a wheelbarrow, you would take this mycelium bacteria powder and the zeolite powder, and you would dust the contents of that wheelbarrow with it.
And
So
we
it's just
like
like, salt.
and we like to
taste.
use wheelbarrows to mix this. We'll use, 5 gallon buckets for 3 parts, 5 gallon bucket for 1 part, so on. In
If
the
that makes sense.
wheelbarrow, we've even used cement mixers to mix this stuff, depending on how much we're making and how much we need and what's going on. We also layer these ingredients in the same proportions. So we'll use this when we're planting fruit trees in the desert. We'll make a big old hole and we'll start layering these things up. The only difference is in the very bottom, we use big chunks of wood, and we also use native soil in the final layer. So this becomes like a huge sponge. And you need a lot less water when you do this method. We also use it when planting riparian area trees, oaks, sycamores, pines, things like that. And that just gives it a really big sponge where it has nutrients for probably at least a decade or more.
Does all of that make sense to everybody? Does anybody have any questions about that? So
we'll also layer this on top of soil, like to regenerate soil. Just do these different layers of compost, fine mulch, fertilizer, etc., on big bare areas as well. And certain people's, we mostly work in residential homes, and some people have big bare areas, and then we'll throw seed in it, and before you know it, that area is being regenerated. So yeah, questions?
That's okay. When you build a spot and you put down your soil in your layers, lasagna, and I think you said it, but like you said, it's good for like 10 years. Is that what you're saying?
There's going to be a decomposition happening in that hole for probably a good decade.
And then is that kind of regenerative? If you're planting things there and they're just kind of keep going, it's just going to keep
It's just going to keep on breaking down, regenerating.
Yeah.
by putting all of that organic matter in there, and primarily the mycelium and the beneficial bacteria. Those are the two components that we're trying to throughout the soil. We want that to spread as quickly as possible. So by layering it up with the other ingredients, we basically make a big host area for them that it can then. So that's the idea. Yeah, is for regeneration.
Any other questions?
Okay. Yeah, you could show. All right. Yeah, for the.
All right. You showed those roots. We have a Mexican Palo Verde tree that is quite large. We've got an issue. We've got a badger that continues to dig 3-foot holes all around that tree. What are we going to do to keep it from dying?
So garlic, society garlic, actual garlic will repel rodents quite effectively. Society garlic or actual garlic bulbs? Society garlic is a perennial garlic that also, in our experience, repels rodents. I don't know about a badger. You said a badger?
Yeah.
I don't know about that. I would do garlic. I would do lots of garlic bulbs or order garlic and plant it all around.
Mm-hmm.
Any other questions on our previous slides? We plant. So
Great question.
the question is, why do we mix these components if we can just layer it? So a lot of times we're adding a small amount of this to a 1 gallon plant or a 5 gallon plant or a 15 gallon plant, even a 25 gallon plant. We don't always layer. The layering is used in water hungry planting systems or plants, fruit trees, preparing area trees. Most of the time, we're just adding a little bit of this mix, just a little bit, to jumpstart the biological activity of the soil. And that's for all lots of sizes. We would never layer for a 1 gallon or a 5 gallon. It's just, it's hard on that plant. Maybe a 15 gallon, sure, but that's why.
It's for larger applications, the layering. If we're planting really large things or if we're planting a lot of things in an area, we'll be doing that layering. But oftentimes we're planting single plants here and there, and having that mix is a lot more practical for singular application. Yeah, right at the bottom of the hole. So you're going to dig the hole. You're going to dig the hole for the plant. You're going to put that mix down at the bottom of the hole and then plant on top.
Mm-hmm. And that mix can go around it too.
Yeah.
The root ball. So this is a very egregious example of root wrap and being root bound. Hopefully, you've never had to deal with stuff like this.
Yeah, this is from an oak tree rescued amongst a few hundred others. And yeah, we had to do some really aggressive root to alleviate that root.
So root care. So most plants that you get from the nursery, you're going to pop them out of the pot, and they're going to have a lot of fine roots that you want to just disturb, get them to understand that they're not in a pot anymore. Rough up those roots. Sometimes on 15 gallons, we'll use snips, hand pruners to rough up the roots, rocks, a little hand trowel, whatever it may be. That way, it can send out new roots from all those areas into the surrounding soil. So sometimes you'll find, like that last picture or something like it, very dense roots around. And that's when you want to shave off, half an inch or so all around that root ball, especially like 15-gallon plants, 5 gallons sometimes. So large woody roots, like you saw in that picture, loppers, hand snips even. And a lot of this comes from this publication right here. It's really important that if you get plants that are root bound, that you take care of their roots, or they will sit there in the hole in the ground and basically be in a pot in the ground. They're not going to send their roots out. They're just going to sit there. You're not going to get good growth. They're not going to be vigorous plants. You're not going to be happy. They're not going to be happy. Picture of a rainwater basin we installed 5-6 years ago. Yeah.
That's a sidewalk. That's the basin with the rain in it.
Hopefully that's clear.
It threw me off. So.
All right, threw you off.
Yeah.
So irrigation and earthworks. So most installations here in Tucson residentially are going to be using drip irrigation. It's efficient, it's slow, it reaches deep root zone penetration because it's slow and deep. It's very easy, it's very consistent. They have anywhere from half-gallon per hour emitters to 20-gallon per hour emitters. We do a lot of that. We do a lot of lifetime, high-quality irrigation, drip irrigation. People hate drip irrigation. People hate their irrigation systems because there's garbage installed all the time. And we're replacing garbage systems all the time. It's unfortunate. Active rainwater harvesting, gutters, tanks, cisterns, pumps. A lot of people are like, yeah, cisterns, and they get one in their yard and they like put a hose to it and like they never use it. Or they use it and it's inefficient. We either hook them up to pumps for your irrigation system or gravity fed in your irrigation system using pressure compensating emitters. With gravity, it works pretty darn well. Larger systems, more water, pumps are great. Flood irrigation. So a lot of you have seen this walking around town. There'll be a plant planted in the sidewalk. There's a bubbler, and that floods that planting area. We use it at our ranch because it's practical and it has a couple of different considerations to get lots of water on the landscape at once. And then hand watering. Hand watering, who tries to hand water their stuff here? Right? Okay. How consistent are you? Yeah. The best of us are like, eh. What I found is you go to Home Depot, buy some 5-gallon buckets, drill some holes in the bottom of them, set them around your plants, and then go out and fill them all up and go back inside your house. It's drip irrigation with buckets by hand water. It works great. Gallon milk jugs or whatever. You know how much water you're putting on your plants.
Good thing.
You know, not so great out there trying to figure out water's running everywhere. 3 wells. That's really helpful for our drip irrigation installs in your buckets. Keep all that water inside that root zone, especially the first year or a growing season. They need that direct water right around their root zones. Then you can start expanding that watering circle. Berms, swale. So a berm is a big mound of dirt. And a swale is right at the bottom of that big mound of dirt and it's a depression. It's usually where you dug out that dirt for the berm. So water runs when it's raining, hits that swale that's depressed and sinks in at the bottom of that berm. And this is a permaculture technique, berms and swales on contour. There's a lot to it. We're not going to get really far into that. You'll see some pictures of it in a little bit. So that's berm and swale system.
Basically, the way the water sheds, so wherever downhill is, right? Where the water sheds, we want to break that up. We want to break that flow up. So the berm is convex, and then the swale is concave, right? So the berm sticking up is going to slow the water down, and the swale is going to enable that water to sink in. Does that make sense?
It's very, very similar.
Say again?
Redirect the water, correct.
And redirect it.
Yeah.
Right.
Yeah, and that's usually called a rolling dip on roadways that directs water.
Mm-hmm.
Basins, swales, swales similar to basins. Basins are larger depressions in the ground that usually can have berms around it, but it's like that picture before. It's a larger area. It's a larger depression to catch that water and hold it in the landscape. And it can look a lot of different ways. It can look like that big area in the previous picture. It can look like a meandering stream, with lots of boulders. It can look like a really deep, steep depression in the ground that's fully rocked, depending on how much space there is. And the rock will help it not collapse in on itself. Rock work, just exactly what I was talking about, in those steep areas to stop erosion or stop blowouts for having so much water in that area. You rock the berms, the basins, so it's stable. And then mulch, as much mulch as you can possibly get. I'm talking, if you can get a layer like that in your basin or on your landscape, do it. Mulch is probably the most crucial component next to like basins and berms and swales. If I'm going to do one thing on somebody's landscape, I'm probably going to put mulch on it. Hey, vegetables. We are going to talk about vegetables. So this,
and it's just pictures now, so we'll let you
just
know.
pictures now.
Yeah.
So this is a vegetable garden that we installed for somebody. What was that? 3-4 years ago?
Yeah. About 3 now.
And she already had raised planters. And she had raised planters that were full of garbage soil, just dirt, just Sonoran dirt. And she wanted to have a
dry
vegetable
Miracle
garden.
Grow.
Yeah, dried up Miracle Grow, right? And she wanted to have a vegetable garden. So what we did is we dug out all that dirt, made sure there's no concrete at the bottom. You want those planters to be open for this system. And we did our layers, wood chunks at the bottom, then a layer of compost, then a layer of fine mulch, then a layer of, X, Y, and Z. We keep on layering that up, keeping in mind that decomposing wood robs the soil of nitrogen. So you want to have a heavy application of compost, right? So when wood breaks down, it robs nitrogen from the soil. If you don't have nitrogen, your plants are not going to be happy. What has nitrogen in it? Compost, fertilizer, organic fertilizer. Keep this in mind. So this happened to be an above ground system. So we got an organic sealant and sealed the inside of all of these to stop water decomposition from breaking down that wall. She was already having issues with that. There's different organic products that are really high quality sealers that we use in this application.
And there's lots of folks that struggle with raised planters, made of whatever material. Having moisture and organic matter in there is going to decay whatever it is that your raised planter is made of. So that's why we suggest finding a sealant, finding something that's going to help that planter live longer. If you are going to be doing this layering system and getting soil activity going. And and another note on that. So that's about raised planters, right? But we also do this in the ground as well for food growing applications. So indigenous folks for a long time here realized that doing their food crops in sunken basins and sunken earthworks optimize growth and water retention, and combining that knowledge and those methods with the layering that we've been talking about has proven really successful for stuff that we've done. Corn, beans, squash, melons, the whole nine. We've had a lot of success with that. So regardless of whether it's a raised planter or in the ground, we still encourage layering organic matter, and it's still basically the same application at scale, so the same amounts, but Yeah, just to clarify that, it's not exclusive to raised planters, but also for in-ground gardening as well.
And then the irrigation we like to use with these is a irrigation tubing that you bury that has copper outlets every 9 inches or a foot that put out 0.9 gallons per hour. And you can bury that in a grid and basically plant right next to each of those emitters.
So imagine a underground drip irrigation. You can find a irrigation source. It's not hard to find. It's a copper line, and
it has copper outlets.
Well, the color of it is copper.
Color of it is copper.
So it has little holes in it, and those holes are where the emitters are. They're inside of the line. So basically, instead of like above ground drip irrigation, where you'd have to worry about your emitters getting clogged and whatnot with dirt, having it in the line like that prevents dirt and whatnot from getting in there, allows the water to still come out. So we suggest that for vegetable garden applications, because we suggest dense planting for that. And that type of irrigation works really well with dense planting. If your setup is a bit more spread out, then you might just stick with normal drip irrigation. But in our experience, planting things closer together than what conventional wisdom typically suggests, and giving it a lot of water with that underground irrigation works great. It's really great in the deserts.
So the layering that you were talking about, do you guys add any loam to that layering system, like sand and silt? Because it seems like it's just a lot of organic matter, and maybe there's
So
no
when we
loam in
layer,
there.
we are layering in native soil, like for the fruit tree plantings and whatnot in the riparian area. Plantings, that layer of native dirt is very important and it's included. In these, for vegetable garden applications, we do not.
Yeah.
The top layer is actually gardening soil that you can get from tanks. So at that top foot or so, we put in gardening soil, high quality gardening soil as well. And, as that mulch on the very top starts breaking down and the gardening soil breaks down, it's going to infiltrate all the way down. You're going to get some of that.
But yeah, anytime we are layering at scale in the ground, we're always trying to integrate it with the native soil that's present there. So whatever we're digging out, we're putting back in small amounts in layers along with all of that organic.
And I think we did actually use a layer or two of native dirt in this install too.
Yeah, I think we did as well. Yeah. Yeah, as well.
So, anyway. I know we're at like an hour or so. Okay, let's roll.
Cool.
Nursery.
Yeah.
Sonora Flora Nursery.
Yeah.
This is a picture of our in-town nursery. This kind of, what? Where is it? It's at 22nd on the freeway. It's not open to the public at the moment, by appointment only. So this all started 3-4 years ago with a friend of ours named Bruce, who is a master oak grower and tree grower.
You guys might know Bruce from Desert Survivors back in the day. He worked there for many, many years.
He's an old friend, acquaintance of ours, and he was growing trees and we were planting them. And it kind of evolved to this point where we had a huge opportunity to buy like 500 oak trees with some sycamores and some pinyon pines from mountain states that terribly abused them, and we rehabbed them with part of it being biological soil mixes, a lot of it being root cutting.
Yeah, that ugly root down stuff that you saw earlier was our first.
Yeah, and we'd have liquid biological mixes that we did dunk those root masses in. That root mass is that big, and once we're done with it, it'd be this big because of how badly it was root bound. And that kind of led to other opportunities with different growers, propagators who were moving from different places and coming to us because they knew we were growing trees and such. And we had an opportunity that we said yes to start up a native plant nursery here in town.
So we are just getting started. We published our second availability list a few days ago, but we're on Instagram and Facebook and all that stuff. So you can take a gander at our wares on there. We also have plants available at EcoGrow. They're on St. Mary's. So if you're looking for native plants, they carry them now, and they are plants that we are growing. So yeah, it really came about working in the landscaping business, needing certain plants, needing them in certain sizes, things like that. And while we have wonderful native plant nurseries here in town and in the area, certain things weren't available. So we started focusing on that kind of stuff, trying to fill the blanks and make available what previously wasn't in the region. So recent developments have kind of made it a bigger project than we initially anticipated. We're just keep growing more and more cool plants. But yeah, it's a really neat thing that is for all of you. So native plants, if you need them, we grow them.
And one of the things that we started out recognizing is I can't get a 15-gallon jojoba very easily or a 15-gallon Baja, fairy duster or a 15-gallon, etc. And I couldn't find high quality 25-gallon trees. They're always garbage. Every time I go to the nursery, crap. It sucks. And I want to plant big trees because I want people to have big trees and shade right away. And what we started doing is growing really high quality 25-gallon trees. We'll water them 4 times a day so they only have a lot of feeder roots and they don't form that tap root that wraps the pot. And then as you put them in the ground and they explode, you get 4 feet a year, all the way, 4 feet of growth a year, all the way around the tree. So that's where a lot of people are like, oh, don't plant 25-gallon trees. Don't do it. It's a bad idea compared to a 5-gallon, blah, blah, blah. It's, well, look at the industry. Look how they're growing these things. Look what's happening to the soil biology. So we were like, we can do this. Yeah. We can do it better. And we kind of can. It did.
Seems to be happening. You can go to the next.
Oh, I want to talk about more nursery stuff.
More trees. Say again?
I want to talk about species.
Oh, sure. Just real quick, want to mention this project here. So this coming Saturday, and I think it's once a month in the coming months, Watershed Management Group is doing a thing.
So they have a new project. Mm-hmm. It's giving food forest kits out so people can plant them in basins. So we have a lot of native plants that bear food that we can eat, So we got contacted by WMG to contract grow for them for this project.
So this weekend we're going to be getting 20 food forest kits to families at the event coming up, but there are going to be more events and more food forest kits available. So if you are interested in that, look into Watershed Management Group's new program because we are
oh, hell yeah.
Hey, look at that. All right.
Get it. You can look it up.
Cool. Excellent.
So, I want to talk a little bit about the species we're growing. So we're growing true Sonoran trees, true Sonoran shrubs, ground covers, etc. We're also growing higher elevation riparian trees. One of the main ones being blue oaks. And there's a reason for that. Blue oaks are one of the few trees that can break through bedrock and raise the water table via hydraulic lift. All right, so we have like 200 blue oaks in 15s and 25 gallons, but we also have pinyon pines. We have 15-foot Texas red oaks. So we are like branching out from not only the true Sonoran basin bottom, but also kind of pushing those limits as well.
Yeah, higher elevation riparian habitats, like Charles said, we're sourcing material throughout southern Arizona. So it's not just exclusive to Tucson, Sonoran flora, but also greater southern Arizona.
And we have 10 different varieties of figs, probably 10 different varieties of pomegranates that we're going to be propagating in spring. So we have heritage grapes, a whole bunch of different types of grapes as well at our ranch, elderberries, so we are expanding into like food as well, much more.
Fruit trees and whatnot.
Yeah. We will be having fruit trees too eventually.
Yeah, these are some of the oaks and sycamores that we were talking about. So we have those in big boxes. And yeah, I mean, I think Charles talked about all of that.
Just a picture for you to look at, really.
There they are. They exist.
So now we're moving on to Strawman Ranch, the ranch where those trees you just saw are housed out by Benson and Mescal. This is a berm and swale system. You can't really see it, but this is the berm. That raised area, this is an area between two berms, and this is the swale. This is that depression. And you can see there's a lot of stuff growing down in there because it's retaining moisture
and
organic matter. We threw big branches in there, all different sizes of organic matter in that depression. That's the swale.
So just to give you a little bit of context on this, the farm at Strawman Ranch is about 3/4 of an acre. We have 13 large berms and swales on contour throughout that 0.75 acres. So there's, like I was talking about earlier, the watershed, the floodplain, and the slope of the land, which we put these earthworks cross-cutting to slow down that flow of water and sink it into the soil. So imagine 13 of these, and then we have 10 to 20-foot walkways that are in between. So you can imagine like rows that you can, traverse up and down. And along those walkways is that depression, the swale, and then up from that is the berm. So you can see over here on this side, this is another berm and swale system, another row, right? And this is the back side of the berm here. So the berm goes up like this, and the swale goes down like that. And then on the other side of this, another walkway, just like that.
And the walkways are all different sizes.
Yeah.
Because it's an organic, very natural system. But when planting in the desert on a system like this, you're looking for about 20-foot spacing. That is to stop the wind and the scorching evaporation. 20-foot spacing, 40-foot tree, do the math. It's going to slow down the wind. The other thing that we have going on here is we have probably 150 different species planted. Probably, have like 400 or 500 plants in the ground, all native to begin with. Everything native, no food other than some wolfberries, some other things that are native that produce food. And then we started adding food.
Yeah.
We have an asparagus patch out there, big old asparagus patch. And we use mistletoe as our green layer when we were layering up our planting area, right? Where do you find lots of green material, which is a very important component of compost, of layering systems? Mistletoe. We got plenty of it. So we have, like I mentioned earlier, a lot of other food stuff. But what? The green material?
Yeah,
Green material.
green material.
Yeah.
Nitrogen.
And as you can see, we have
You can go to the next slide, actually.
a whole bunch of straw bales.
I think the next slide will have it.
Whole bunch of straw bales. And this is a really big row.
Yeah.
This is the biggest one by far. And here's this straw, about 130 straw bales that we flaked on top of all our berms.
So broke them apart. If you've ever broken apart a straw bale before, it breaks apart in layers.
Flakes. Then
That's
compost. Then cow manure from Golden Rule Dairy, where they don't use any nasty stuff in their shit. So we've spread all that on this too, layering those nutrients just in a different way out here and on a much different scale.
And then, so how do we irrigate all of it? The berms have flood irrigation on them. So every 10 feet, we put a bubbler that does a quarter gallon per minute
to 1 gallon.
To 1 gallon per minute. You can change the emitters on those. So we did that on some of them. But basically, that irrigation spacing is every 10 feet. And what we're doing around these bubblers is we're gilding plants, right? So we'll plant a native tree. We'll plant 1 or 2 native shrubs. We'll get a ground cover in there. We're trying to fill all those different plant
layers
in a forest community, right? And have all of that stuff benefiting from the irrigation that's right there. So we have some mulberry trees here, but we have that directly integrated with a bunch of native stuff as well.
And something that was really important in this process, which happened recently, is we mulched all these rows. That was bare dirt before. And what we're doing is we're trying to get that connectivity from one berm and swale to the other via mycelium, via beneficial bacteria. We used horse bedding from tanks, and that really changed the dynamic out there. From bare dirt, and it's not covered thick. It's minimally covered, but we started seeing a lot of things growing in the middle, finally. And there's an energy out there where it feels much more connected now. Because before it was just bare dirt and they were not connected. It didn't feel like from one berm to the other was a synergistic system of harmony or whatever you want to call it.
Mm-hmm. So yeah, just covering every inch of bare dirt is really what has enabled us to get good soil biology and good soil health going. So yeah, the same thing applies to our landscapes and our gardens here. Mulch. Get as much of it as you can.
Totally. So that's another thing about this mulch. We've put this in town in yards, 2 inches thick. It will cool the place by 5 degrees. 5 degrees. It's a huge thing in how hot our cities are getting with climate change and everything, and for your enjoyment and pleasure.
Mm-hmm. Hand raise.
Sure. I have a hill that I've been slowly putting trees and building shade. Mm-hmm. And I have pathways, but they're just dirt. And so if I understand you correctly, then I should be putting fine mulch to help connect it as an ecosystem, even though I don't want to grow anything there. Okay. Thank you.
Yeah, and a cool thing about mulch as well is that in thicker applications, it helps to suppress weeds and stuff from growing.
You got 2 inches of mulch, you get no weeds, 5 degrees of cooling, better soil biology, water retention. A lot of the stuff, if you buy the right stuff, you can walk on it barefoot. If you're into that, it's super nice. It smells good. I mean, it does ticks all the boxes. I go on about it for a while. It will certainly tamp down the dustiness too.
Yeah, because depleted soils, tend to blow around.
And you want to make sure you get small mulch, because the bigger you get, the more air gaps you have in it, and the more dust can blow in, and then weeds can grow in that. So it's important to have small wood
chips. That's why we emphasize the finer wood chip mulch, the play safe stuff,
or horse bedding.
Because it doesn't really allow for it fills all those little gaps, so that it's a lot more difficult for dust, weeds, seeds to blow in. I think we only have like 1 or 2 more cool pictures to look at.
That's the asparagus patch. That's asparagus that's this tall.
Yeah, we planted it last spring.
You can grow asparagus too.
From root crowns. So they basically just cut it down to the roots and then just send you that.
And there's lots of stuff. There's Datura in there and all types of weeds. I mean, we did weed it in spring, but we just kind of let it roll. And that's down in the swale. That's down in the swale. And then we took bubblers and stuck them down in here as well. And we layered that with mistletoe and gardening soil and mulch and all the things we've been talking about. And that just rocks. I mean, that's
so this is an example of a sunken bed, right? Sunken basin.
Which is swale
that has all of the soil components that we were talking about earlier, the amendments layered up in there. And then we planted the root crowns densely, a little closer than the spacing that was suggested. And we do the flood irrigation with the bubblers. And I mean, it's going crazy. It's very, very healthy, happy asparagus.
Coming to a market near you soon.
Yeah. We have to wait another year or so before we start cutting on it. So I don't know if anybody's tried growing asparagus or has learned anything about it before, but they do suggest waiting a couple of years before you go cutting it, because that will help. It's rhizomial, it spreads through the roots, so it helps it to get really well established and strong before you start cutting it, so that it'll last a lot longer. If you cut asparagus too early, then it sends that signal to the rest of the plant to regrow, and it doesn't have as much structural integrity to do that from, right? If that makes sense. So the longer you wait, the better it is, basically. And that's it. Yeah, so that's another cool picture of the ranch. And yeah, we're happy to take any questions. Or
how many people are on Zoom? All right.
4 people.
We miss you. Sorry you couldn't make it.
We have cutter ants that's chewing up our chili tapine plants, cutting them to pieces. Our Mexican trees are cutting all the leaves. What can you do? Looks like we're gonna lose our Mexican Palo Verde, and now we're losing everything.
Good luck. I mean, we have a desert willow. We have a desert willow that every year gets fully defoliated. No leaves left.
By leaf cutter.
And then it just comes back. I mean, people have tried lots of different things with ants. None of it really works. I mean, like some of the top ant researchers and people who work with seeds and ants eating seeds. I mean, there's nothing you can do. I don't know anything about grasshoppers.
So I think if we could say anything about in dealing with messing with our plants,
listen to the man.
By doing integrated planting, right, where we're trying to grow as many different things as we can in one area, we're inviting a lot of different critters to come and hang out. And what happens is that creates competition, predation, to where we have a lot of beneficial insects that are coming in and taking care of the pests. So the best thing that you can do to make sure that your plants are not susceptible to pests is plant different things around. Plant different things around it. They're going to bring in other insects. They're going to keep those guys in check.
Or plant on your edges everything that they love, so they'll get those in easy spots, and they might leave your stuff alone too. That's another permaculture principle.
Yeah, totally. You can plant for pests. If you see that the pests like certain plants, you can plant more of those somewhere else. And that can redirect. I think that person behind you was first, so one sec. Oh, sure. One sec. True. That's totally true.
Propagate some lizards. Propagate some lizards. I love it. Yeah. It's just from the tail cut. It's just like pomegranates. You just take tail cuts. Yeah. And some water.
I'm wondering about timers to put on rain tanks to water plants in my absence, gravity fed.
Yeah.
Do you have any suggestions?
You're worried about them?
Yeah, where I can get some.
Oh yeah. So Yardine and Toro make zero gravity timers. Yardine.
Okay.
Yeah, J-A-R-D.
Why? I like Yardine. We use Yardine for gravity fed irrigation systems off tanks.
Okay. And what was the other one?
Toro has one. I don't like it.
Okay.
I don't suggest it.
But yeah, they're typically
Zero gravity.
it's just like inline battery operated timer that just has a couple of knobs on it. It's very easy to navigate. Yeah.
Yeah, it says zero pressure timer.
Yeah, you do want to
No
make
pressure.
sure that it does say zero gravity or zero pressure. Anything else? Any other questions, comments? Yeah, true. Thank you, everybody.
Thank you.
Have a wonderful evening.
Thank you guys so much. That was super informative. And if you want to find these guys, you can find them on Instagram and Facebook, I believe. Earthcare Landscapes and Sonora Flora. We do have a giveaway. Yeah. Oh, and there is the watershed management event this weekend. So also we do have a giveaway for anyone who got a raffle. I do not have the details about that, but Melanie does.
The Zoom instructions, I think. Just what I said before, I'm teaching a class on Thursday, lunch, and then I'm teaching a class